Now let's take a look at alcohols. So what are those? Of course, we are going to start with fundamental things such as showing what the alcohol functional group is supposed to be. So basically, when you have the carbon atom, right, attached to the OH group, to the hydroxy group, then you are going to have the alcohol functional group. So overall, what you need to do is figure out some sort of typically for our course intents and purposes, we're going to be concerned with an sp3 hybridized carbon, right? So just think about some sort of CH2, for example, attached to an OH, right? So of course, OH group can be attached to, for example, sp2 hybridized carbons, but in this case, the situation will become a little bit more difficult, a little bit more complex in terms of identification of the functional group, because the functional groups in this course are kind of limited, and then in organic chemistry at large, there are many more various functional groups that can be kind of tricky, right? But for now, we're just going to be concerned with some sort of like sp3 hybridized carbon, which is attached to an OH group. So overall, the combination of COH atoms like this, right, will give us the alcohol functional group, right? So now let's take a look at the like examples. So for instance, you might start with the simplest possible alcohol, which will be CH3OH. So that's going to be the first representative of alcohols in the row of alcoholic compounds, as they say, right? And then typically we need to start with something kind of like simplest, right? So be that carboxylic acids or alcohols or alkanes, as you know already. And then based on those simpler compounds, we're able to explore more difficult compounds. Basically, it's about just the increase of the molecular weight with which the increase in complexity comes as well, right? So CH3OH so also is known as methanol. So perhaps you know about this compound from your general experience, right? So then the second kind of compound in the alcohol row will be even more popular. It's going to be called like this. It looks like this, CH3CH2OH, right? If we were to spell it out, and it's called ethanol, right? So ethanol is very popular a compound because it can be used in a lot of applications, right? Perhaps if you are more inclined to deal with medicals, you might have heard of isopropanol. Isopropanol is another example of a popular alcohol, right? So I think, as a matter of fact, your book talks about some sort of popular alcohols. So basically, we have here propanol, right? Then, if you recall, to make isopropyl, right, an alkyl substituent, all you need to do is chop off one of the H's and then make it CH right here, right? And then you are going to attach, guess what, OH. And now you see this common topic, right? COH piece will be like, this is OH bond right here. COH piece will be visible here, which signifies that you have the alcohol. And this structure right here is going to be called isopropanol, right? So just verbally expressing that. So it's going to be isopropanol. And here we go. So this is your examples of alcohols with respective functional group that is embedded into already 3 different structures, right? So then now let's take a look at the nomenclature of alcohols. From the point of nomenclature, so what we need to do is, of course, look at some examples, right? So because again, you have the rules in the book and the slides, so, but it's going to be a very good idea to just get into examples, right? Because we can like look at the rules infinitely, but if we cannot apply them, then what's the usage of those, right? So let's take a look at some kind of example of the alcohol with a relatively long chain. So let's show the condensed structure, which is going to be looking something like that. So we'll start with the methyl, then we have CH, CH again, CH2 and CH3, right? And of course, so I'm leaving some like hydrogens out because I'm going to attach substituents instead of those removed hydrogens, right? And here we have our finally OH group attached to the sp3, as I promised, hybridized carbon. And then you have here the alcohol, right? So functional group within this molecule. Of course, you have the alkane chain, right? And then alkyl substituent, for example. But overall, you do have the alcohol here, and you might call this molecule an alcohol, right? So if you see that functional group. So then now let's look at the numbering of the chain, right? So oftentimes we need to number the chain, and then we're going to number it from the end, which is closer to the location of the hydroxy or OH group. This is OH group, hydroxy, in other words. So you should be familiar with that term from your Gen Chem experience. So we're going to number it 1, 2, 3, 4, 5. If we number it from this end, so the OH group will be not on carbon number 2, but on carbon number 4. And then 2 is lower number, so lower number beats the higher number. So that's why we're numbering the chain left to right in this particular example. So then we're going to, again, kind of like put together the pieces of the name, right? So we'll start with the root, right? So that corresponds to the longest chain. We need to identify the longest chain, by the way, right? So that's what I kind of skipped. But anyway, so here we have 4 carbons in a chain, and this is going to be the 5-carbon chain. This is going to be our winner. So what's 5, right? So what's the root that stands for the fact that you have 5 carbons in the main chain? So that's going to be pent. So penta rather, right? So penta. And then for alcohols, we use almost the same root as in alkanes, right? So except we're going to remove the letter E, right? So for example, if you have just an alkane from 5 carbons, you are going to have pentane, right? So for alcohols, we're going to use the name pentane without E, right? So pentane, right? So then what do we do next, right? So pentane is anyway the root that tells you that you have 5 carbons in the chain, right? In the main chain of this alcohol. To signify that we are going to have alcohol, we are just going to cap the root piece with the suffix ol, right? So pentanol, pentanol. So then we're going to show where our alcohol is at, right? So namely, we're going to show where the OH groups is connected to the carbon to make overall, holistically, the alcohol function group. So OH is located on carbon number 2. So to make alcohol function group. On carbon number 2, we have the OH that makes an alcohol from in the 5-membered chain, 2-pentanol, right? On the second carbon, there is an OH that makes an alcohol from pentane, essentially, right? So that's like how you can wrap your mind around it. Of course, like with more examples, it will become kind of like more natural. It will become more of the fingertip feeling, if you will, right? So then we're going to beef it up with our substituents and their locations, or location and substituent, right? Strictly speaking. So on carbon number 3, we have methyl, right? So this is going to be our methyl on carbon number 3, right? So let's put it this way: 3-methyl, 3-methyl, sorry, 3-methyl dash 2-pentanol, right? So that's it. So that's going to be your name of an alcohol explained. So last but not least, in this mini segment, we're going to take a look at the phenols. Phenols are special kinds of alcohols, which again will have to bear the OH group. But in this case, what's going to happen is that we will step away from our original notion of alcohols, right? So where we have the sp3 carbon that bears the OH group, right? So in phenols, we are going to have the sp2 carbon attached to the OH group. So then phenols will be kind of like a special kind of alcohols, right? So here we go. So you are going to deal with an aromatic alcohol in this case. So which is going to be looking something like that. So we have our H's here. So as you see, you can consider phenol an alcohol, right? So you can also consider that as a substituted substituted benzene, right? So basically, if you look at this structure carefully, right? So if you recall what benzene is going to be just C6H6, right? So, but then via chemical reactions of some sort, you removed one of those H's, this H on the top, let's say, right? And then you switch that H on the top to an OH group. So now you have the phenol. So that's a special kind of alcohol. So it's going to be called phenol. So that's what phenol looks like. So remember this structure because those are very popular compounds again. So they can be used a lot in various forms of organic synthesis. And then also phenol structure in a modified fashion, right? So maybe instead of like this H is going to be some kind of like isopropyl, can be found in natural products. Let's take a look at the classification of alcohols, and they can be classified as primary, secondary, tertiary. So the best thing here is just to take a look at the examples, right, of those structures. So let's start with the primary alcohols. So that could be, for example, just let's take a look at propanol, right? So one propanol, so meaning that OH is attached to carbon number one. So let's draw this, right? So basically here you need to notice the pattern, right? So that happens to be in primary alcohols. So that's a primary alcohol, right? OH group is attached to the carbon, which only is attached in turn to one carbon, right? So let's kind of like put the dot here. Maybe let's put some kind of like highlighter here, right? So highlighter here. So you see this like alcoholic carbon. So that's the carbon which is directly attached to the OH group. It has the CO bond, right? So let's call it alcoholic carbon. And then we're going to count how many carbons this carbon is attached to in turn, right? So only one. So this carbon is not attached to this alcoholic carbon, right? So it's too far. So between this carbon and that carbon, there is a bond, right? So if you draw the expanded structure, right? So then you will see there is going to be a carbon-carbon bond. At this point, you need to be able to do that if you like want to be successful in this course, right? So that's one of those indispensable skills. So now let's move to the secondary alcohol, right? So then you can sense that I'm going to highlight those carbons which I count, right, which are attached to the alcoholic carbon. Let's show isopropanol, right? So like if you are like a medicinal person, right, so then you will encounter isopropanol at some point, which is going to be looking like this: CH3, CH, CH3, right? And here we have OH. So this is going to be a secondary alcohol. Why? So let's note just mentally the alcoholic carbon, this one, right? So this carbon is directly with one bond attached to the oxygen, right? So now let's count the carbons, number of the carbons which are attached to the alcoholic carbon. 1, 2, attached, attached. So this is a secondary alcohol. You see, one gray circle, primary, two gray circles, secondary. So it's all congruent. So now finally, tertiary alcohol. Well, guess what? I think you can figure it out already, right? So just pause the video and then like try to predict what it could be, right? So I'm giving you a hint. Remove this H and switch it to, for example, to a methyl, right? Nice and simple. So let's draw that. So here we go. So CH3, right? Then C, CH3 again, OH, and as I promised, here's a switch. So now, guess what? By the same token, we are going to notice our alcoholic carbon is this one, right? I don't highlight it. So which is attached to directly to the OH group. Okay, good. So now I'm going to count and highlight the carbon numbers, the number of carbons which are attached directly to the alcoholic carbon. 1, oh, sorry, that's the wrong tool. 1, 2, 3. 3 carbons, 3 gray circles, tertiary. 3 gray circles, tertiary alcohol. All nice and congruent.